Hey everyone, welcome back to another SAT math video. This is a question from the 2024 official practice bundle 6 math module 1. In right triangle ABC, angle C is the right angle and BC is equal to 162. Point D on side AB is connected by a line segment with point E on side AC such that line segment DE is parallel to side BC and CE is equal to 2AE. What is the length of line segment DE? Whoa, this question is crazy. There's so many different things. I don't even know where to begin. Well, maybe you're thinking that after reading that question. Lucky for you, it's actually not that complicated if you know how to break it down. So, anytime we have geometrical problems like this, or where you have to do stuff with triangles and all that, it's usually best to start by drawing it all out, right? So we know we have some right triangle, right? So right triangle means the triangle has a right angle, right? And we know that this will be our point A. And then since uh, C is the right angle, so we know that this would be right here, B, and then this one is going to be C, right? So we have some line BC is going to be 162, and we know AB is connected by a line segment with point E. Oh, we got point D, right? So point D is on side AB. So let's just say point D is here, and it is connected by a line segment with point E on side AC. So AC is here, and we know that there is some point E such that line segment DE is parallel to BC. So we know our point E is going to be right here. E is going to be on AC, and they told us that DE is parallel, so this line segment DE is parallel to line BC, and they're telling us that CE is equal to 2 of AE, right? So they're basically telling us that this length right here between these two is going to be double of the length over here between A and E, right? So let's keep on annotating. We know that, well, since this E line DE is parallel to line BC, we know that this has to be a right angle as well, right? And since we know that this length is, let's just say some length x, right? We know that CE is 2 of AEs, right? So if AE is length x, we know that CE is going to be 2x, right? So now we have some more information to try and basically figure out what the length of DE is, right? Because that's what they're asking us. They're asking us what is the length of this line segment here, okay? So what we know now is when you have two triangles kind of inset on one another like this, where we have like a smaller triangle that's basically just a portion of a larger triangle, that means these two triangles are similar triangles. And what that means is they will be related by some sort of scale factor, right? Because they are similar, their side lengths will all have the same ratios with each other, and this smaller triangle is some scaled down version of the larger triangle, or the larger triangle scaled down by the sum factor is the smaller triangle, right? So basically, all we need to figure out is what is the scale factor between the larger and smaller triangles, right? Well, one of the hints they gave us, right, is CE is equal to 2AE, right? We have this hint right here telling us that this length CE is just 2 times the length of AE. So what does that tell us between the length of AE versus AC in total, right? So if we have AE, right, AE is the leg of the smaller triangle. Let's just say that that's going to be X, right? What is the length AC? Well, AC would simply be X plus 2X. In other words, 3X, right? So we know that these lengths or these legs, right, AE and AC, they correspond to the same legs on the triangles, right? This length AE would correspond to the larger length AC on the scaled up version of the triangle, right? So now we know, okay, basically, uh, the lengths on the smaller triangle, right, that we have here on the smaller triangle are basically just going to be 3 times or what their length is in the smaller triangle in the bigger triangle, right? And that was evident right here, right? Because we know AE is equal to X and AC is equal to 3X. Therefore, we know the relationship between the smaller triangle and the bigger triangle is that the smaller triangle is basically timesed by 3 to get the bigger triangle, right? Hopefully that makes sense to you guys. So all we have to do basically is just kind of come up with this scale factor. And now what we can do is use that to our advantage to figure out what the length of ED is, right? Because notice we already have the actual length of CB, and CB is like the bottom leg. And we know that, okay, this bottom leg in the big triangle, when scaled down, is going to be the length of the bottom leg in the smaller triangle, right? And how do we scale it down? We scale it down by our scale factor, which we know to be 3, right? Which we figured out right here, right? So all we got to do to scale down this length to figure out what the leg is going to be in the smaller triangle is basically divide the length in the bigger triangle by the scale factor. So all we got to do is 162 and divide that by 3. Okay, so you can do this in your calculator. I'm going to do it by hand because I'm crazy like that and like to do math. So 3 goes into 16 5 times, then we get 1 left over, right? And then we bring down to 2, and then 3 goes into 12 4 times, and that is going to give us a remainder of 0. So we basically solved this. So we know that 162 divided by 3 is going to give us 54. And there you have it. That is going to be the length of ED. It will be 54. So that's all you gotta do for this problem. It looks like a lot, but once you break it down and draw it all out, it becomes a lot easier. So in recap, all we had to do was first draw out our triangles and draw out our diagram according to how they described it in the question. And then we had to realize that these two triangles within this diagram are similar triangles that are related by some sort of scale factor. We then use this relationship right here to determine the scale factor itself between the smaller triangle and the bigger triangle, and we knew that this was 3 was a scale factor because we were able to relate the lengths of 2 corresponding legs between the smaller triangle and the big triangle, and then using that scale factor we were able to scale down the bottom leg in the bigger triangle to figure out what the bottom leg's length in the smaller triangle was going to be. So hopefully that made sense. Let me know in the comments below if there's any way I can improve these videos and make these more clear. Check out Khan Academy. They have a lot of great resources on SAT and ACT, as well as other subjects if you are into learning. And as always, thank you so much for watching, and I'll see you in the next one.